Howdy, everybody in YouTube land. What we have in front of us today is, well, I don't know what the hell this thing is, but what I do know is it appears to be in various state of disrepair and it has mindset on the front of it. Now, this was sent to me for repair. I don't know anything about it. I've never had one of these apart. I've never even seen one of these. And quite honestly, I don't even know what it is. I don't know if it's a game console. I'm judging it's just by the way things look on the front. It's some computer thingy, but I really don't know much else outside of that. I'm not even gonna bother plugging this thing and turning it on because I mean it's just being held together with tape. There's loose bits rattling around inside, so honestly, I don't know what I'm going to expect. So we're just gonna take this thing straight apart. All right, so I have the phone mounted on the wall mount here. Try to make this a little easier. This used to have a webcam on it, but the picture quality was so terrible on that webcam, I decided to get rid of it. So, let's see, what do we have here? Well, we've got some. Well, that looks very Smashco twinkulated. I don't know much of what's going on here. I don't know anything about this computer at all. I've got no keyboard, I've got no mouse, I've got no monitor, I've got nothing. So I may not even be able to test this thing. But what I do understand is what the original owner has told me is that this machine, the schematics just recently came out on this hardware. I don't know. I don't know this world at all. And apparently, I just made a Twitter post on this machine saying, hey, someone sent it in for repair, and it blew up. Because apparently, from what I understand, these things are rare. So, there we go. Oh, yeah, that got jammed. I don't know what this is about or why. But, wow, we even got a little motor here. This thing's kind of cool looking. I've not seen anything like, oh, there's a CPU under there. Actually, you know what that is? I wonder if that's a 286 because I have one sitting up on top of my keyboard here. This came from a Compact Portable 2, I think, because, not proud to admit it, back in the mid 2000s, I want to say, I got my hands on a Compact Portable 2 and I was playing with it, but this was before XT IDE and all this other stuff. The hard drive was bad and I couldn't get anything working with it, and I ended up parting it out. I kept some of the parts, scrapped some of the parts, that kind of thing. So, unfortunately, it is what it is. But this is not supposed to look like that. Something happened here. I don't know what's going on there, but that's broken. I'm pretty sure that is that's, I don't know what in the world. I have no, I don't have the slightest idea. I'm sorry, but this is not something I'm used to. Let's see, what do we got over here? Oh, the screws. So the screws were taken off. Oh, that's a cute little container. Never seen anything like that before. Then we have some chippily doodly doos over there. Let's see. Oh, that's not good. The wires have come off this, looks like an RF modulator. Let's see, sometimes these get loose and cause problems. Chances are I'm not going to have the monitor here. This thing's probably some proprietary monitor. This is strange to me. I don't know why. That doesn't seem right. This is not. What in Sam Hill? I don't know what. Does it go like this? No. Oh yeah, this thing definitely broke off. There's a piece missing here, I think. This is... Oh, I hate these clips too. These are notoriously used on like tube radios. I mean, I don't know. I am well out of my element here. This is not... Oh, well, that makes it easier to get out. Yeah, this is... That just kind of fell out of there. Okay. Card edge connectors. So it looks like it takes cartridges. Kind of reminds me of something like the PC Junior. I wonder if it's like, maybe it's PC Junior compatible. I don't know. Well, we've got a section here that won't come apart. No, there's no screws there. There we go. It came right off. Oh boy. I wonder. Well, I don't know. This thing's probably too old for that, though. Let's see. What are the date codes we have here? We have 1984. Oh yeah, it's too old for the leaky capacitor syndrome. 84. So this was made before I was born. So this computer is older than I am. But let's see, what do we got back here? Oh, we got these wet tantalum capacitors. These things short. So that could be a problem. But we've also got this weird motor thing here. Oh, that's a fan. Oh, wow. So this is made before those little brushless DC fans were a thing. Oh, that's seized. It's gonna need some oil. We've also got this big relay looking thing here. You know, one thing I've noticed right away? There are no power switches. Where's the power switch? There's no... Oh, reefa! Got a reefa capacitor in there. That's got to come out. But there's no... Yikes. So... I don't know, is this an actual, like, PC? See, I don't know what these look custom. These are probably the video controller. I'm just guessing. I don't actually know. BIOS. The fact I see BIOS makes me think this is a PC. So this is like an Intel 286 PC, maybe? Let's see, 8042 keyboard controller. 8742. I'm not sure what that is. Not off the top of my head. Maybe that's where the keyboard goes. That would make a lot of sense. There's no ISA bus or 8-bit bus. There's none of that here. My thought process on that is perhaps that's what these are for. These are like 8-bit expansion ports. This would be their version of what they think the ISA slot is. Maybe that's what this is. This is an ISA. Well, that would make a lot of sense, wouldn't it? Because ISA expansion. Because maybe there's something else that sits on top. That's why this expansion port's posed. Maybe disk drives or hard drive or modems or something like that. This is all the ISA bus. This is probably just a bare bones basic 8-bit. And then we have a ROM bus over here for the front cartridges. It's memory expansion. RAM expansion. Maybe that's RAM. It's one thing I don't see on this. Where's the RAM? TMS 4416. Maybe that's them. Yeah, I do not. Other than those 4 chips right there, I don't see RAM. So perhaps these front cartridge ports are RAM expansion modules. That would make a lot of sense, because if your RAM expansion's up front and then your peripherals are back here, like modems and serial ports and disk drives and all of that, this is probably just a PC. A very weird PC with lots of bodge wires. But more importantly, there's no way to turn this thing on. There's no power switch. I'm not plugging it in either, because there's reefa caps in there that have to come out. Actually, you know what? I think that's what I'm going to do. I'm going to take the power supply out and inspect it and see what we got going on, because yeah, there's also this big ass relay here. What the frick does that do? You know what? I'm starting to suspect. Ooh, that's broke. I'm starting to suspect that this thing has some kind of early form of soft power, maybe? That's why this relay is there? The power supply might run all the time and this just feeds current out to the board. I don't know. But this right here has me really concerned, because someone's been tinkering with the RF output module. So maybe this is bad and someone was trying to isolate the problem. I don't know. I'm just guessing at this point. So we got to start somewhere, and unfortunately, I don't know where to start because we don't have the rest of the stuff. All I have is this. This is it. This is all I got. So there's only so much testing I'm going to be able to do without the rest of it. I don't see any Micron RAM, so we're good there. Let's see, what can I do? I suppose I could take the power supply out, because we know we got to remove those reefas, so I think that's what we'll do. We'll take this power supply out and see what we got going on inside there, because that's the path of least resistance from what I can see, the path of known control. Let's see here. Never had one of these machines, so I have no idea what to expect. I'm sure there's probably a million YouTube videos on this thing. I haven't looked yet. But as soon as I say, let's see. Apparently they didn't make many of these, because there's a serial number here. It says serial number 000589. So yeah, so they didn't make many of these. This is probably rare, to be honest. Alright, so we have you, and of course, we've got a ground wire there, and it's using something that's not a Phillips. Why? Good question. Let's see if it's 1/4 inch. It is. Got lucky there. So I can move that off to the side. Yeah, looks like it's a fork anyways. It would have slid out. Oh well, whatever. So we have a power supply. There's the fan. So I got to figure out how to oil that fan. So for now, we're just gonna move this stuff out of the way. And we're going to take this thing apart, because I don't know what we're dealing with as far as how everything looks inside here. Let's take a look-see. It's never been apart before, because I'm seeing metal shavings come out when I unscrew these. Yeah, that's done. Alright, well, that's not a big deal though. So before I even attempt to even power this computer up, I need to see the inside of this thing, and also I got to get the reefa out, because the reefa cannot be in there Unless I want to have a smoke show. There's a lot of screws in this thing. A lot of them. Alright, so there we go. That came out. Oh, there was foam in there at one time. Not anymore. Okay. She's got some hours on. Holy crap, look how fried the board is. Wow. Okay. Alright, well that screw's got to come out. I didn't want to take it out, but guess what? I have to. See, how is it held in here? Looks like it's just kind of sitting in there. And of course we've got... Yeah, that's going to be fun to deal with. Because... Yep, there's a nut right there. That is not going to want to come out. If you haven't been able to tell, I am right-handed, so I can't maneuver it this way very easily. Alright, so not want to come out, guys. It's being very, very stubborn. There we go. Oh, it's so cute. I've never seen a choke set up like that before. Ugh, not how I wanted to get it out, but okay. Alright, so get you over there. Whew, that's not as bad as I thought it was gonna be. I was gonna suspect that it would have like bad solder joints, and in some cases it does. Especially here. Is that a 2-layer board? No, so that doesn't even go anywhere. Yeah, some of these solder joints are very, very questionable. Like there, you probably can't see it well on the camera, but there's some of these that are definitely suspicious. Actually, there's quite a number of them. So now, it looks like they've got these little daughter cards in here. See, how do they look? Not terrible, but definitely not great either. So 1983, she bit old. These are probably all traditional ESR. And here's the thing about these, because you can see the heat scorching here. So this thing got really, really hot, which scares me if these caps are dried out. These types of caps, these are old enough, they don't really leak per se. I don't see them leaking. The big thing about these is they dry out. Like the fluid slowly evaporates, especially with heat. It's accelerated by heat. And that is what happens to a lot of these. See, 10 volt, I don't know what the value is. 1000 microfarad, 10 volt. We've gone a long way since then. They're a lot smaller now. So these are 1000 mic at 10 volt. This one's 330 at 16. 330 at 16. 47 at 6.3, which I think I have some 47s now, fortunately. The rest of these I can't tell because I can't get to them, so I have to remove those. So those minimum probably need replaced because of the amount of heat scorching. The rest of these are to be determined. 300 volts DC. So the big item for here, for me anyways, is, whoa, look at that. Look how scorched that one is. That one's really bad. This early switching power supply stuff, man, I swear. 100 UF, 200 volt. I don't know what that one is, probably the same. Because usually the way these 120, 240 jumpers work is they put these caps in series parallel based on how this jumper is set up to step up the voltage. Oh yeah, it's threaded, that's cool. Anyways, I'm going to pull you out, get you out of my way because you're in my way. The big thing for me in this case is to remove the reefa. Because the reefa, that's a big one. That will make some serious mess. So, God, you know, I don't like it when they fold these leads over. Because it makes it much harder to get out. Because I bet that was my biggest fear right there, and it's taking the copper up with it. Yeah, that's there we go. Let's get this bomb out of there. Is that what happens? When this cap was new, this was clear. I remember that. I remember that distinctly. And it's turned yellow with age and it's cracking. So what happens is when it does that, these absorb moisture. And it's just like a traditional paper film capacitor like from the 50s and 60s. And when they absorb moisture, pow! That's what happens. They get leaky. And when they get leaky, it starts drawing current. When they draw current, they get really, really hot. And then when they get really hot, they go boom. So I'm going to leave that out for now. I don't think I have any of these. That's a big one. That's a 0.6 microfarad. I got 0.1s, but not any 0.6s. But it'll work fine without that anyways. I'm leaving it out. But the rest of this, on the other hand, if I were to guess, it probably runs fine, but I don't know. I am curious though how these capacitors test. So I think what I'm going to do is I'm going to remove all those caps and get them written down, which I don't have to do that on video. I'm going to get all that written down and then we'll check them just to see what they test like. I just pulled off these riser cards just to kind of get them out of my way. And this is my biggest pet peeve in the industry right here. That IC has been scratched off. I don't know what that is. So if that chip is bad, this power supply is junk. And this, oh, this is a nightmare. And then this one here has a house part number. So it's disheartening when I see stuff like that. It really, really is. I pulled the array of 3 capacitors out, which kind of go right here. And sure enough, they're not leaking, but this one's getting ready to blow its guts right out the bottom here. And that's where the vent is, because the vent's not on the top on these caps. They're on the bottom, and they're hidden behind those rubber plugs. And yeah, that one's getting a bit done. And you can see how, just kind of how baked they are, just from heat. So I am curious how they test. And these were probably all green at one time, but they're definitely done. So they've got to go. I'm not surprised. I mean, they're 40 plus years old, so it's time. It's time. Yeah, all those capacitors are roached. They're all supposed to be this green color, and in some cases they kind of still are, but not really. They're done. They're all supposed to be this color right here. So, yeah. Alright, so I got the basic recap done, the exception of these primary filter caps. I'm not going to check those just yet. First things first is, obviously I want to test the power supply, but before I do, I actually want to check these capacitors and see how bad they really are. Alright, so, first one's first. Let's check this big 4700 micro. This is away from the heatsink, so I don't expect much to be actually wrong with it, but we shall see. No. So the problem with this thing is it's not very intuitive how to use. So, nothing. $87 milliohms? No. Yeah, I'm not really getting much with this thing. 3200. This is a 4700 cap. No. It's weak. Alright, so these are the ones that I really want to check. So the first one is a 680 at 16 volts. Actually, nope, that's the wrong way around. It goes this way. Yeah, 1 ohm ESR at 376, so it's reading half of what it's supposed to, so that's shot. The other one's barely readable. 1000 at 10. So we're gonna do 1000 at 10. not too far off, but the ESR it's bad. It's bad. So, okay. Then the next one is the same exact one. See how bad you are. High ESR, but capacitance is only a little low, so they're bad. They're definitely bad. They're not terrible. I mean, would the power supply still run? Likely. This is a 330 at 25. Let's see what you check like. You always have to be suspicious of capacitors that read higher of their rating. That usually means they're leaky electrically, and I don't mean physically. 230. Yeah, no. It's 100 microfarads off of where it needs to be. Those are for sure shot. This one is a 330 at 16, so this one should be really reading around there. That's actually not far off. This cap is still good. And that one's still good. But makes sense because this is away from the heat zone. Yeah, same thing. So both of these are okay. Now this is the 47 at 25 volt. Let's see what you got. Yeah, 14 ohms. It can't even read the capacitance. It's just leaky. It's literally that leaky. So that's done. Okay, this is an axial leaded 4.7 at 50. So see what you read at. I mean, it's out of tolerance, but it would still work. This is a 1 mic at 50 volt. $500 ohms. No junk. Yep, they're all shot. They're all bad. Well, except for a couple. A couple of these were a little low, but still usable. The rest of them are shot. Let's see, 250 volt, 0.6. Let's see what you read at. Yeah, it's good. Well, relatively. From an electrical characteristic, it's fine. But I wouldn't expect it not to be because it's a film cap. So, alright. There we go with that. So at this point, it's a matter of figuring out how in the world I'm going to turn this thing on, because I don't know. So let's get this thing put back together and get it back in the machine so we can test it. Actually, before I do, I want to check, because these are 100 mic at 200 volt. I want to check these because I'm curious. Now, these are going to be hard to test in circuit, but I do want to check and see. $106 microfarad. That one's dead on. Next one should be the same. Yeah, they're fine. This is why I don't change the primary filter caps, because generally they're okay. And just in this case it is. They're dead on. Now the capacitance is reading a little bit higher, and that could be for a couple reasons. One, it's in circuit, and two, they could be electrically leaky a tiny bit. They might need to reform a little bit. I don't know, but we'll see. All the other ones are replaced though, so we should be able to fire this thing up. But before I do, I'm going to get it back together. Alright, so power supply is back in the machine, so we need to get this thing plugged in here. So that's what we're going to do. We're going to plug you in. Alright, nothing blew up. I don't hear any clicks, so there's no lights on the front anywhere at all. So I'm not having high hopes. Let's find a ground point. Let's check U. Well, we got 5.4 volts there. Negative 12 volts. .4 volts there. Positive 12 volts. So the power supply is running. These two don't appear to have anything. Let me find out why. Oh yeah, that's ground. That's why. That's why. Okay, so we have a functional power supply. I'm happy about that. Power supply is working, but we don't have anything else. See, do I have 5 volts to the rest of the system? Well, let's check you. No, I don't. I do there. I have 5 volts there. 5 volts there. Oh yeah, that's warm. Yeah, it's on. Yeah, we got power. That chip's warm. So 5.4 volts. 5.4. Nothing here. So it's like we've got 5.4 volts to some of the circuitry. Nothing there, nothing. Okay, so let's see, 74, 245. Nope. Nope. So that I find interesting. Some of these circuits are energized, but the rest of them are not. So that means there is a soft start switching circuit somewhere in here, because I get 5 volts coming out of this power supply. So I know the power supply is running, and I am getting some voltage to some of these ICs, especially this one because it's getting warm. RAM is not. Some of these are. None, that one's not. That's warm. That one's warm. Cold, cold, cold. So half the circuit's energized, the other half's not. Okay. That's warm. Yeah. We got, the crystal is getting warm. Let's see. No. Nothing there. I'm just flying in the blind at the moment. I don't even have... No, I'm not sensing any voltage anywhere in here. Oh! Oh! That's new. It didn't like that at all. That must be the main system clock. Really? Okay. If you take that crystal out, all the lights come on. And it starts screaming a buzzing beeper at you, which is this guy here. So this thing is energized, and I hear this relay click. So yes, it does indeed have a soft start circuit. It's waiting. You know what? You know what? It wouldn't surprise me because the keyboard... Is the keyboard controller energized? I can't tell. I don't think so. No, maybe not. My theory was perhaps the keyboard has a little soft power button on it somewhere. And this thing, keyboard controller, picks it up and clicks it on and everything powers on. So without the keyboard, I can't do anything. So this project is lost before I even get started. But it is running. The power supply's on. Wow, this thing gets warm quickly. So that's why, you know what? That's why this thing looked like it was so baked with all these caps. Because this power supply runs whether the computer is on or not, and the fan is on or not. So that scares me. Alright. So at this point, I'm going to go grab the schematic, and I'm going to go find out how I can energize this machine. because honestly, I don't know. Sometimes these can become problematic too. Yeah, you gotta grind these down and solder them because these use those crimped RCA jacks. These are very common with like Apple IIs and stuff like that, and they always fuck up. So, but yeah, I mean, it's coming on, it's working, but I don't have a keyboard or EGA display or anything to plug into it. We still have this we need to deal with. I don't know why that's been removed. So, I guess this would be on like channel 3, channel 4. I could plug this into like a TV and see. But also we have that too, composite. So I can plug a composite monitor in here and see what's going on. Something's up with that, but first off, let's get a schematic. After doing some quick research on the internet, I've come to the conclusion that this is not an IBM compatible PC. It's similar, it's using the x86 architecture, but it is not IBM compatible. This is its own beast. So I'm going to take everything I know and throw it out the window. But this is using a 186 CPU, which I don't think any IBM compatible ever used. It's funny because the 286 has got the same style package. Anyways, so I had to check that out. Also, I found the schematics and I did a quick glance, and this chip here, which is energized, that chip is the system controller, which in a modern system, you have, like a laptop, you have the EC chip, which handles the keyboard and ACPI and all this other stuff. When you're thinking about flashing a BIOS, there's a ec.bin file which flashes the embedded controller. This is the predecessor to that. And there's two of them here. There's one for the audio, so we're going to eliminate that. But then we have this right here. This is the EC chip. But if we take a look, we have a power on signal which turns on the whole system. So this chip gets a signal from somewhere to turn the system on. So I wonder if this is handling the keyboard as well, which it could be, because I see keyboard KB something here. So if this is also handling the keyboard, that would make a lot of sense. Because this thing could be looking at a scan code or something on the keyboard and it says, hey, I'm here, and it wakes up and turns it on. So without a keyboard, getting this thing to turn on is going to be really difficult. So yeah, we're going to have to keep probing at this a bit. Print out another one because it got cut off. But that could very well explain why when I removed this crystal back here, this thing turned on and started freaking out. It's because I'm removing the clock signal from this controller chip here. So then what happens is all the outputs get activated. So we got a buzzer continually going on. We have the power kicking on. Everything kicks on because we've essentially just eliminated the clock signal here. So that makes a lot of sense. And now that I have the rest of this exposed, we have a keyboard select and all this other stuff. So that could explain a lot here. So we have J1, which I think J1 is the keyboard connector. That's what I need to look at. So J1, we have keyboard data, and then keyboard something. Frequency select, FM receiver. This is weird. This is definitely something weird. You know what? I don't know if there's a keyboard emulator for these things, because without that, getting this thing to work, even with a generic keyboard, is going to be hard, because I guarantee this is not an AT compliant keyboard. So, I might end up throwing the towel in here. I'll see if I can't get it to turn on and see if I can get some kind of screen up on it. I don't know, but once beyond that point, I think we're basically dead in the water. So, pin 4 is the trickle 12 volt. Looks like pin 3, 5, and 6 are grounded. And then 1 and 2 are your data, and then whatever that is. This is a terrible scan. Better than nothing, but it's horrible. I just committed the biggest mistake of my life right here. So I looked at that CPU and I went to go put this freaking clip back on. Snap! Brittle plastic disease strikes again. That's junk. I don't know where I'm going to find that socket. Alright, well, TubeTime is sending me a new socket for that. We're going to move on from there. From now, I'm concerned because the schematic for the keyboard connector shows a different wiring than that of the, hold on, pulling something up real quick. So this is the keyboard diagram. There's the power button, as far as I can tell. And it's going to like pin 3 of this, and then pin 5 looks like it's the data going out. Well, if we look at the schematic, that is not what we got here. And even then, we have a 12 volt trickle coming in, but then up here, we've got all 4 connected to ground, and it's a different... So there's something funky with that cable. I don't have the cable, so I don't know what's going on here. I don't have the keyboard either, so this is confusing. We have a data pin, but we also have this keyboard present pin. I don't know if there's supposed to be like a pulse connected there or what. I need the keyboard so I can do some reverse engineering. Because apparently, from what I'm understanding, is the keyboard for this thing is kind of rare now, obviously. And there's people who own these without the keyboards. And as far as I know, there's nothing in the community yet that has any way to adapt anything to it. So perhaps that's what this video becomes about. We adapt something to make this thing work. I might have actually hit a dead end here because BitSavers already has the ROMs dumped and has everything dumped and everything archived. And it says right here that when the power switch is turned on, it sends a burst of characters and it turns on the relay. That makes more sense. Because, yeah, we have a power switch here, but I think that power switch, all it does is tell this schematic or this circuit to enable the keyboard. And as soon as the keyboard gets enabled, the keyboard, I guess the keyboard energizes, and when it does, it sends out a burst of characters. And I don't know what those characters are, but I'm going to presume that burst of characters is what tells this guy to turn on. So you have to have the keyboard. Or perhaps we can make a keyboard emulator. But the good news is, at least everything about this keyboard is documented. We've got pictures, we've got, a picture of the circuit board and all that stuff. But we also have... Well, let's see, where is it? There we go. We also have the key matrix, so we could make a keyboard using like modern Cherry Keys MX or something like that. And then the ROM is right here. What I don't know is what CPU it has. So perhaps, I don't know if this is the same 8742. I can't tell. Maybe that's an 87. Yeah, I'm thinking it is. It's either an 8742 or maybe an 8749. Oh, yeah. I got to see if I can locate an 8749. And then burn that ROM. Because the problem is I cannot find at all a disassembler for this series of chips. IDA doesn't support it. MAME might, but I'm not sure how to do it in MAME. So yeah, that's fun. Because if I can disassemble the ROM, I can figure out what character bursts it sends out and then create some sort of an emulator. Wow, this is a nightmare. Enough time has passed where I finally have a replacement socket to replace this one that broke. That was kind of silly. Anyway, so this one was sent to me by TubeTime. He had an extra one, so we're going to go ahead and install that and fix this problem and get it out of the way. Alright, so I got the board pulled out to replace this socket, and I kind of like this board design. You know, these vintage boards just have a certain aesthetic to them that aren't replicated in modern designs. Just the way the layers stacked up, the type of masking they use. It's, I don't know how to put a finger on it, but anyways, the other thing I wanted to note too is there's quite a few bodges on this thing. There's quite a number of them, but not like, you know, the TRS 80. So nothing like that. But anyways, there's the socket that I need to extract and replace. There. The processor socket is installed with the processor back in there. And the thing about these sockets, it's made out of the same kind of plastic that SIM sockets are made out of that constantly break. The little fingers break. It's the same plastic, and this thing is under tension. So it's no surprise that this one broke. Now, I tried to glue it, but yeah. Anyway, so it had to be replaced. So we fast forward a little bit more time. Oh, I took care of the jacks in the rear by adding a little bit of a solder blob because they tend to break free. So that's done. But fast forward a little bit of time, man. We have procured a keyboard. I can see why the keyboards are constantly missing from these machines. So what we're going to do is plug this guy in. And this keyboard has a switch on the rear. And I forget exactly how the switch is wired in the circuit. But at least now we have a keyboard. So that means, in theory, it should work. Now, remember, the schematic wasn't making a whole lot of sense with how the keyboard is wired into the unit. So, I think I'll be able to do a better understanding of what's going on here if I take this keyboard apart. I'll mark those differences in the schematic because otherwise it doesn't make sense. Anyways, let's see. Does the keyboard work? It does. Alright. Now I have a monitor hooked up so I can see what in the world's going on. So, here we go. Oh, we got something. Whoa, that's weird. It's very... I don't know if it's supposed to do that or not. I have no idea. That looks like bad video chip. Just by how it's acting. Whoa, that's cool. Well, the reset button doesn't work. Nothing does, actually. Touching any of these keys, it doesn't do anything. But I'm not sure what the expected behavior is on a machine like this, but that seems kind of strange. Power cycle it. Yeah, we got, look what's happening here. I don't think that's normal. I think we have a bad video chip, and if that's the case, we're done. There's no fixing that. What in the world is going on with this thing? It's a very weird behavior. I'm going to have to look at the schematic and see if I can't find the schematic on the video hardware. Because that seems very strange. Oh, look at that. Yeah, that's a no. That's a no. That's not good. All right. Well, clearly I have more research to do. You know, I kind of wonder if it's a counter signal that's not getting a reset pulse somewhere in here that's... Yeah, that's very weird. Because I can cycle the power, and the state of the video hardware is random when it comes to this. Which almost makes me think there's a flip-flop or something in here that's not getting a pulse. Yeah, look at this. That is not good. That is really, really screaming. It's not the RAM of the video memory. It's not the graphics processor. That is the read processor. So it's divided into two chips. You have the graphics processor and the read processor, which is the frame buffer processor. That frame buffer processor is bad. Notice it's increasing in speed too. Yeah, that's in that processor. It's junk. Look what the vertical blanking interrupt is doing. That's not normal. That right there will cause everything we got going on here. Because I'm checking both blanking interrupts. And the chip is just, it's freaking out because it doesn't have a stable vertical blanking reference. I got to figure out where that comes from. It might be the chip itself generating that. And if that's the case, it's a bad chip. But I got to double check that. So I froze the chip and I didn't really get any difference here. So what we've got going on is this early vertical blanking period and this blanking period. That's the interrupt that goes back to the 8186, which is working fine. So this output may not be correct, but it's not causing any problems on the CPU side. Moving right along, I decided to check the composite sinks, the blank, and the burst gate. That's all good. I even checked this signal here, which is a vertical drive going out to the RGB connector or whatever. That's also good. So whatever is going on here is internal to this chip, which unfortunately is this guy right here, this VC2029. So I'm going to suspect that it's bad. So I've got the keyboard working. I just was having a dumb moment and not actually knowing what I'm doing. And I can adjust the vertical height, which my thought process here is it's actually modifying a register inside this chip. And that register is working. See? Which rules out the inability of the CPU being able to access the registers in that chip. So that is working. It's that chip, it's bad. So I've also checked everything here. It's all good there. And I checked these two flip-flops. We have this frame reset flip-flop. And this doesn't get a signal. It's coming off of here. But what I ended up doing was taking pin 2 and just momentarily grounding it, like glitching it, which will trigger this frame reset input. And it does reset the frame's position, but it doesn't stop it from crawling up the frame buffer like it's doing. So the way this works is this is like DMA. It reads the data off the bus through these muxes out of these chips right here. Yeah, so it's able to read and write those chips without throwing an error. So that tells me that we don't have a problem with RAM access. We don't have a problem with the RAM access, anything like that. So it's looking more and more that this guy here has gone bad. It has. And I can't find this chip anywhere. So it's almost like the NES's PPU, you know, they go bad, they go bad. So unfortunately, that's going to be it for this one. I wish I could do more with it. I wish I could have had a good conclusion with this one after even already getting a new socket for that. But unfortunately, that's just the law of the land sometimes. So that's it for this one, ladies and gentlemen. I can't go any further than that, unfortunately. So anyways, I'm going to send this guy back to its original owner, and we're going to move on to the next one. So if you have a comment, please feel free to leave one. Don't forget to hit the like and subscribe and all of that fun stuff. Until next time, guys, thank you for watching. So there has been an update. I sent the machine back to its original owner, and I had indicated that the read processor was defective and that it needed to be replaced. That was just the bet that I put and what my gut was telling me. So But he was able to locate a replacement read processor, and I am happy to report that after he replaced that read processor, everything is working perfectly fine. It fixed the problem, and the machine is now fully functional. And I am so happy that it wasn't anything else on the board. My gut was telling me that that read processor was bad. So there is good news. There is good news. I sent the machine back to the original owner. He replaced that chip, and it works perfectly fine. It's awesome. I'm glad to see that we were able to take care of it, and this video wasn't a total failure. And it was a long one too, but you know what? In the end, we got the machine working.